Okay, last example in lesson 2.5. And as I said, I believe this goes with maybe the last two problems in homework, I think it was, 34 and 36. So, given the complex number z equals 1 minus 2i is a 0. Okay, so that is a given 0 of that f of x function. Find the remaining zeros and write its linear factorization. So our answer is going to look a lot like the previous problem did, where we're going to use some synthetic, we might have to solve an equation, whatever it takes here, but we're going to find all of our zeros. And so right here, let's see, we have 1 0. What can you tell me about the number of zeros we're going to have here total? Yeah, by the time we get done with this problem, right, we know, because of that 4 right there, that there should be 4 zeros, right? And we are currently given 1 minus 2i. Now, thoughts on that 1 minus 2i? If we're given 1 minus 2i, remember complex conjugate zeros theorem? If a plus bi is a 0, then so is a minus bi. So if 1 minus 2i is a 0, then so is 1 plus 2i. Okay, so we do have 2 of our 4 zeros. We need to find the remaining zeros and write its linear factorization. Okay. A lot of times we say start with PRs. And if I recall correctly, you graph this one, you're not going to find any PR. I mean, we can list our PRs if we want to, but when we graph it, there's not going to be anything. If they give you a 0 to start with, let's start with that 0. So they're giving us 1 minus 2i, so we're going to start with that 0. And yes, we're going to use synthetic division. Okay? So, let's set it up. In my box is 1 minus 2i. And if I recall correctly, yeah, I'm going to kind of space my numbers out a little bit because I need a little bit of room to write here. So in my row of numbers, there's 4, 17. Ooh, wait, nope. You guys got Mrs. Sargent's mistake?
You need to put a 0.
Yeah, I need to put a 0, don't I? 4, because that's x to the 4th. 0 is x to the 3rd. Then 17x to the 2nd. 14x. And a 65. Yes? Okay. Well, here we go. Drop the 4. And then we multiply. What is 4 times 1 minus 2i?
4 minus 8.
4 minus 8i? Just think distributive, right? We take 4 times 1 minus 2i and you distribute that. 4 times 1 is 4. 4 times minus 2i and minus 8i. Then we're going to add 0 plus 4 minus 8i is going to be 4 minus 8i. Now what? We need to multiply. What are we multiplying?
Do you have to FOIL this?
Maybe. Okay, so we're multiplying 1 minus 2i and 4 minus 8i. So yes, we're going to FOIL. Now, because I want to be able to show the work and not lose anybody, I'm going to bring it down here so I can actually FOIL on screen and not just try and FOIL in my head. I mean, I could FOIL this in my head, but I want to make sure we don't lose anybody. Okay, so FOIL. 1 times 4 is 4. 1 times minus 8i, minus 8i. Negative 2i times 4, minus 8i. Negative 2i times negative 8i. plus 16i squared. Clean that up. What's that clean up to be? I've got a 4 here. Minus 8i and minus 8i is going to be minus 16i. What about 16i squared?
It equals -16.
It's negative or minus 16, right? Because 16 times negative 1, that's going to be minus 16. So 4 minus 16 is going to be negative 12 minus 16i is what I would say on that. And where do I put that negative 12 minus 16i? That's going under the 17. And then we're going to add. You guys got to talk to me here. I want to make sure we know what we're doing. How do we add 17 and negative 12 minus 16i? Like terms there are 17 and minus 12. 17 and negative 12 are 5. And then we still have, I said 16, didn't I? Wait a minute, where's my mistake? It is supposed to be 16i. I just didn't write it up there. Correct? Yeah. So 5 minus 16i. Now what? We get to FOIL again, yes? Okay, so I'm going to bring it down here. This time I'm FOILing 1 minus 2i and 5 minus 16i. 1 times 5 is 5. 1 times minus 16i is minus 16i. Negative 2i times 5 minus 10i. Negative 2i times negative 16i. Negative times negative is positive 32i squared. Clean it up. We've got a 5 here. Plus 32i squared is really going to be minus 32. And 5 minus 32 is negative 27. Negative 16i minus 10i. I'm going to say minus 26i. Stop me if I do my math wrong. Where am I putting that negative 27 minus 26i? Up under the 14. And now what?
How did you cancel out the 32i squared?
So 30, because I squared is negative 1. So it becomes 32 times negative 1, which is minus 32. And so I did 5 minus 32, which is negative 27. Okay? We all good otherwise? What's our next step? We're going to have to add, right? 14 is a whole number, so it adds to be with the negative 27. 14 and negative 27 should be negative 13 minus 26i. And one last time, we need to FOIL. So I'm FOILing 1 minus 2i times negative 27 minus 26i. Last FOIL. Oh yeah. Oh yeah. That's a big mistake. Thank you. Okay, I grabbed from the wrong place. Sorry. Yep, the added. Negative 13 minus 26i. Woo. Grabbed from the right place. Okay, now I'm ready to FOIL. 1 times negative 13, negative 13. 1 times minus 26i, minus 26i. Negative 2i times negative 13, plus 26i. Negative 2i times negative 26i. Negative times negative is positive. 2 times 26 is 52 I squared. What do you see happening here? Yeah, 26 i's cancel. That's good news, considering we're expecting a remainder of 0 here in a moment. Okay, negative 13. And what do you know about that plus 52i squared? Yeah, this is the same. I squared is negative 1 times 52. So that's minus 52, isn't it? What is negative 13 minus 52? Negative 65. Put the negative 65 up in our problem. And 65 plus negative 65 is 0. So yes, it does work out, believe it or not. Okay? Okay, then we follow that. It takes a little work. It's doable, though. It's just math. It's all stuff you know. You just have to be careful. Okay, so we have a remainder of 0 here. Have a remainder of 0, so as we knew it would, 1 minus 2i worked. Now what?
Do you use those values with the conjugate of it?
Yes. So now we need to use 1 plus 2i, and we need to use our new row of values, though. Good news, I promise the math is easier. I promise it is. Give it a chance. Okay? So now, I'm going to use 1 plus 2i. I'm going to set up synthetic division again. Yes, the numbers look weird, but that actually works to our benefit. Okay, so set those up there. So I'm going to have 4 minus 8i, 5 minus 16i, negative 13 minus 26i. And we start by dropping the 4. And then we're going to multiply. What is 4 times 1 plus 2i? Distribute again, and it's 4 times 1 is 4, 4 times 2i is 8i, so 4 plus 8i. Four plus 4 is 8, but minus 8i plus 8i cancel, which is what makes this second part of the problem much better. The first one was rough, this one's much better. So now again we're going to multiply. What's 8 times 1 plus 2i? Distribute there, and we have 8 plus 16i. Because 8 times 1 is 8. 8 times 2i is 16i. Then we're going to add. 5 plus 8 is 13. Minus 16i plus 16i, again, cancel. Then we're going to multiply again. 13 times 1 plus 2i. So 13 times 1 is 13. 13 times 2i is 26i. And then guess what happens? We add those and we have remainder of 0. Okay, so once the first one, yes, is rough. Not going to argue that. There was a lot of foiling. It was rough. However, once you get the first one, the conjugate is a little easier, right? We didn't have all the foiling. Now what? What does 483 represent? That's 4x squared plus 8x plus 13. And we can set that equal to 0. Obviously, I mean, if there were some real zeros on the graph, you could use those as well. But there's not. Okay? So we have to go and look at this to figure out what we have left. How do we find, we need 2 more zeros. How do I find my remaining 2 zeros? Technically either or. I would encourage quadratic formula over complete the square, just because complete the square, when we start throwing in fractions, which we would here, it would get messier.
So this sucker doesn't do product of AC as well either.
It does not. Now, that is a valid thing. You can check that. But I will tell you right now, Ethan, it does not do product of AC. Okay? And here's the deal. If it did product of AC, we'd have rational factors. So you'd have factors that you could see on your graph. Okay? So, quadratic formula, here we go. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. You guys are okay with quadratic formula, right? I didn't say the numbers I filled in, but I said the formula. So negative 8 plus or minus 64 minus 16 times 13. It's going to be some negative value, right? So 64 minus that 4 times 4 times 13. I have written down that it's negative 144 all over 8. Okay. What do you know about the square root of negative 144? What else do we know about that? What do we know about the square root of 144?
It's 12.
It's 12. So, we'll take a couple of steps with this. Negative 8 plus or minus the square root of negative 144, then is going to be 12i. So negative 8 plus or minus 12i all over 8. Obviously, I don't always all simplify like that one, but this one did. What do you know about 8, 12, and 8? They all divide by a factor of 4. So we can simplify this. So if we're going to divide them all by, well, okay, we can divide them all by a factor of 4, depending which way I want to say this. Or you can put 8 underneath both pieces. And actually, as I looked at this, we do need to separate the pieces. So think about it this way. Negative 8 divided by 8 is going to be negative 1. What's 12i over 8? If we take the 12 and 8 and we divide both of those by 4, we have 3/2 I. Okay. So what I did is I took the 8 and I put it under both pieces. Negative 8 divided by 8 is negative 1. 12i over 8, well, 12/8 reduces to be 3/2, so I said 3/2 I. Now, what do we have right here?
2.
We have 2 more zeros here, don't we? So we had 2 zeros to begin with, the given plus its conjugate, and now we just found 2 more zeros. So now we're ready to write an answer out. How are we asked to write this answer? Linear factorization. We'll write it out. Write it out one way. We have some fractions in it, so I'm going to talk about another way as well. Before I forget, because I forget this every stinking year. These are all factors, right? We need to keep in mind also that there's an A value. Okay? There's not always an A value. On the problem we did yesterday, there wasn't no A value, so I didn't think to point it out to you. This time, do we have an A value? And I'm talking for the original problem, right? Obviously not the A from my quadratic formula here, but we have that A value. So you always need to incorporate, if the A value is other than 1, you need to incorporate that in front of your linear factors. Okay, let's see if I can, I'm going to start it right here. So f of x equals, I'm going to start by having a 4, and then, okay, x minus, the first 0 they gave us was 1 minus 2i. So if I subtract 1 minus 2i, that's going to be x minus 1 and plus 2i. That's me writing it without the extra parentheses like we did yesterday. So that's the first 0. The next one, x minus, and this time I'm subtracting the quantity 1 plus 2i. So if I subtract 1 and subtract 2i, it's going to be x minus 1 minus 2i. Then the next one, x minus, and this time I'm using negative 1 plus 3/2 i. So if I do x minus, we're going to minus negative 1, which is plus 1, and we're going to subtract a positive 3i. So I'm going to say 3/2 i. So I'm going to say minus 3/2 i. And then the last one, x minus, this time I'm subtracting negative 1 minus 3/2 i. So if I subtract a negative 1, that becomes plus 1. And if I subtract a negative 3/2 i, that becomes plus 3/2 i. That is one version of your answer. That is not the version the answer key would give. Wanted to double check that before I said that. Okay, in my brain, yes, this is equivalent. I agree, this is equivalent, we've done all the work. But the answer key is going to not be crazy about the idea that you have some fractions in here. Now, there is a way to take care of that because we also happen to have this A value of 4 out front, and that A value of 4 out front can help us take care of the fractions. Okay, so what we can do, luckily for us, 4 is the same as 2 times 2, yes? And what do we need to get rid of this fraction right here that has a denominator of 2? You have to be able to multiply by 2. What do you need to get rid of this fraction that has a denominator of 2? You need to be able to multiply by 2. And so what you will see them do is they're going to take this 4, I kind of want to write this out here, and they're going to take this 4 and they're going to distribute it to these other parentheses. First of all, they're going to distribute a 2 to this parenthesis, and then they're going to distribute a 2 to this parenthesis. And note, 2 times 2 is 4. So when you get to that final answer, you won't actually have that 4 out front because we would have taken one of the 2's and multiplied by this parenthesis, and we'll take the other 2 and multiply by the other parenthesis. Those first 2 parentheses didn't have fractions, we don't have to worry about. We're trying to get rid of the fractions here, which is why we're taking a 2 to each of those parentheses. Now, totally different story if we didn't have an A value of 4 out front. Okay, honestly, they tend to give you an a value that makes it able to happen. So you ready to multiply with me for final answer? F of x equals, so there's no longer going to be the 4 out front. I'm going to have x minus 1 plus 2i. I'm going to have x minus 1 minus 2i. Okay, this third set of parentheses has a denominator of 2 I want to get rid of. So I'm going to multiply that entire set of parentheses by 2. So what was x plus 1 minus 3 halves I, multiply it by 2, so it becomes 2x plus 2 minus 3i. And the last set of parentheses also has a denominator of 2. I have that 2 I'm going to multiply through by, so I'm going to multiply everything in the parentheses by 2, and so it becomes 2x plus 2 plus 3i. And that is what a final book answer would look like. And again, these are both good, valid answers, but I want you to be able to understand what they're doing with that a value of 4. Okay? Questions I can answer. Okay. And this is why hopefully you got the homework at least started last night, because there's some big problems in here. I want you guys, not leaving everything to the last minute tonight. And hopefully, if there's some questions, I can answer some of those today as well, if there's things you're stuck on and whatnot. So use the time to work on some homework. Page 215, 2 through 36 evens. Again, if there's questions I can answer, things I can help with, please let me do that, okay?